Okay, in this video we will continue to practice using our trig identities to find the value of trig functions. So looking at problem number 7, I see the sine function right there and the sine function's right there. So I'm going to use the primary Pythagorean identity. So I know that sine squared theta plus cosine squared theta is equal to 1. So I can take this 1/3 and substitute it in. So that's going to give me 1/3 squared plus cosine squared theta is equal to 1. Well, that is going to be 1/9 plus cosine squared theta is equal to 1. Now I will subtract 1/9 from both sides. And I like to think of the number 1 as a chameleon type number. If I need a denominator of 9, then 1 can become 9/9. So now I have cosine squared theta is equal to 9/9 minus 1/9 is 8/9. I need to take the square root to unsquare this. Don't forget, for now it's plus or minus. So good old cosine theta is going to equal plus or minus radical 8 over 3. Now let's decide if it's positive or negative before we go any further. We're talking about between pi over 2 and pi. So we're talking about the second quadrant. Cosine is definitely negative in the second quadrant because on the unit circle cosine is the x value and x values are negative to the left. So we will have to keep the negative sign on this one. But what we really want is the secant function. So knowing that the secant is the reciprocal of the cosine function, then we're just going to take this reciprocal. So that'll be negative 3 over radical 8. Alright, let's do one more example on this video. Cotangent this time. So I see cotangent right here, so I'm going to use this version of the identity. Alright, so 1 plus cotangent theta is equal to the cotangent squared theta is equal to cosecant squared theta. Alright, so given that, I can take this 1/2 and substitute it in. So this will give me 1 plus 1/2 squared is equal to cosecant squared theta. So this will be 1 plus 1/4. But this 1 is very much a chameleon type number. I need a denominator 4, so I can write 1 as 4/4. So when you add this up, you get 5/4 is equal to cosecant squared theta. Then you need to take the square root of both sides. Don't forget that your solution will be positive or negative. So that gives me cosecant theta is equal to plus or minus radical 5 over 2. Now what we want is the sine function. So we know that sine is the reciprocal of cosecant. So if I want the sine of theta, I'll do the reciprocal of this. So this will be plus or minus 2 over radical 5. Now, will it be positive or negative? Well, just pay attention to what quadrant you're talking about. So if you glance at the unit circle, the direction said between 180 degrees and 270. Well, 180 degrees is right here, and here's 270. So clearly we are speaking about the third quadrant. And sine is negative in the third quadrant. So there you go. Alright, those two problems only took 5 minutes, so let's go ahead and power through and do these last two examples on the same video. So I'm seeing tangent right there, so I'm going to use this version of the identity. So that means I've got tangent squared theta plus 1 is equal to secant squared theta. So I can go ahead and put this in for tangent. So that's going to make negative 2/3 squared plus 1 is equal to secant squared theta. That's going to make positive 4/9 plus 1 is equal to secant squared theta. 1 is a chameleon, so if I need a denominator of 9, I can rewrite 1 as 9/9. So that is going to give me 13. So I've got 13/9 is equal to the secant squared theta. So now I would take the square root of both sides. Alright, but when you do the square root, don't forget your plus or minus on the solution side. So that's going to make this just plain old secant theta equals plus or minus radical 13 over 3. Went ahead and took the square root of that 9. But we want the cosine function. But we know that cosine is the reciprocal of secant. So that's going to make this plus or minus 3 over radical 13. So that's basically the answer, but we just need to figure out will it be actually positive or negative. So take a glance at our diagram of a unit circle. The direction said between 90 degrees and 180 degrees. Well, there's 90 degrees, there's 180 degrees. So we are talking about the second quadrant. And cosine is going to be negative over here, because on the unit circle, cosine is the x value, and x values are negative over here to the left. So we will just call it negative 3 over radical 13. Alright, so that was number 9. Last example, number 10. And we're using the sine function, I see, so we might as well use the primary Pythagorean identity. So we know that sine squared theta plus cosine squared theta is equal to 1. I can substitute this in, so that's going to make 6/7 squared plus cosine squared theta is equal to 1. Well, this is 36 over 49 plus cosine squared theta is equal to 1. But then I would subtract 36 over 49 from both sides. Remembering that 1 is sort of a chameleon number. I'm going to need like denominators, so I really need a 49. But I can replace 1 with 49 over 49. So now I will have cosine squared theta is equal to, now 49 minus 36. So we've got 13 over 49, and we need to take the square root. So if we take the square root of both sides, don't forget to do plus or minus whenever you take the square root of both sides. So that's going to give us plain old cosine theta is equal to plus or minus radical 13 over 7. Went ahead and took the square root of the 49. But we were asked to find the secant. Well, the relationship is that the secant is the reciprocal of the cosine. Well, before I do that final answer, let's decide if it's positive or negative. Okay, so let's look at a quick diagram of the unit circle. The directions say between 0 and 90 degrees. Well, 0 and 90 degrees, that's just the first quadrant. All right, and everything is positive in the first quadrant. All right, so we can erase this and just go with positive radical 13 over 7. So like I was saying, secant is the reciprocal, so this will be 7 over radical 13. So that would be the answer. All right, I have not been rationalizing the denominators, but since this is the last problem, let me just remind you that if we wanted to, or like say if you're taking the SATs or something, and you do a problem like this, and you're getting 7 over radical 13, but then you look at your choices, and that's not one of the choices. Well, maybe you need to rationalize your denominator. So you can do that by multiplying the numerator and denominator by the radical. So that's going to make this 7 radical 13 over 13. Okay, so this is equivalent to that. All right, guys. I hope this video has been helpful. I'll see you on the next video.